All right, class. You just finished doing the developing design solutions section, and now we're going on to the communication design solution. This is the very final step in your engineering process. We find out what the solution is, or the problem, excuse me. Then you brainstorm ideas, pick one, you create the item, which you are in the process of creating your robot and your bridge. The very last step is you want to communicate it. We're going to communicate it several different ways. We are going to be using an engineering drawing, and that's the drawing you created for your bridge. The final step is to have that detailed drawing. So if you look at here, there's 3 engineering drawings that are commonly used. It shows everything you need to know to create and build that product. Now, we're not going to create a systems drawing. That's going to show you how everything works. You're going to explain your system to a group in your panel. You're going to explain the system to them, not draw it out. Now, the assembly drawing would be, if we did one, would basically show how to recreate or assemble the parts to make your robot. If we did that, it would take all year, so we're not going to do that. The only thing I require you to do is do a detailed sketch of your bridge. Okay, so you're going to have a front view, a top, and a right side view. Most of you have already done it because I made you do it before you can print it out. But those are the 3 types. Your system shows everything, how it flows together. How does your robot work with the bridge? How does your robot get the food that you pick up through the cave? So that's kind of what engineering drawings would be. In the real world, think about this. Assembly drawings, again, you go to Walmart, you buy something and you have to put it together. It's going to provide you a assembly drawing to show you how to put those things together. Now, your system drawing might be, if you buy a computer, and I know they don't do as much as they used to, but they used to create a system on how you plug the certain cords into the computer. How does everything work together to complete what you need to be done? All the things you need to get finished. Okay. Go back to detailed drawings because this is what you did. A lot of this is review. If you look at it, the object, how many sides are there on every object? It's a trick question. If you look at it, you see 3, but there's 6. 6 drawings on every object. In the orthographic projection, which is also called multi-view method or multi-view drawings, we're only going to focus on 3 of them. Now, sometimes you don't need to do 3, and we're going to talk about that. It depends on the complexity of the product or the part, is if you're going to draw 1, 2, or 3. Most common is 3, but if you have a cylinder, you could probably get away with 1. Okay, a cylinder, basically a pop bottle. If you think about it, it's symmetrical. You could pull a leader, not leader, as in the liquid, but it's basically an arrow pointing off of it and saying the dimensions or the diameter of it, and not have to worry about the top view. So you can do it from the front view if you wanted to, and it should be sufficient. But most common is 3 view drawings, but on those 3 views, you should have every dimension or all the information you need to complete that part. Okay, we use what we call orthographic projection. Again, we project up over that 45-degree angle I've showed you guys in class. But first thing, you got to make sure you use the front view, and that's the one that has the most detailed and the fewest hidden dimensions or details on it. Okay, so that, again, orthographic projection is the same thing as what we call multi-view drawings. We just create this drawing so someone else can complete your product. Okay. Things that are included on this drawing, you've got your dimensions, size dimensions, your locate holes, any angles on it. It's called a geometry dimension. So again, we're going to put everything on this drawing to make sure that someone else can take your product and go create it. Okay. One thing I want to talk about real quick is tolerance. Okay. Tolerance is something given. If you think about it, how much tolerance does your parents have on you? Okay, that's kind of the leeway given. In manufacturing, you have to worry about a tolerance. I've got a friend of mine who's in the airplane industry, and he's a quality control. One of his employees he was working with was off the product itself. I believe it was around $12,000 product, and he was off by 0.003. That is the size of a hair. If you say off by a hair, literally that was off by a hair, and he had to throw it away. The part was bad. Think about the airplane industry or even the shuttle industry, the NASA, their tolerances are so high because we have to have perfection. Now, when you're working with your robots, your tolerance might be not as small as 0.003 of an inch. It might be an eighth of an inch, a quarter of an inch. But when you start building your bridges, you're going to realize either it's messed up or not, but it still works. So your tolerance isn't as high in depth. Okay, so tolerance is a word you need to know, understand, because of there are a lot of tolerances around us when we start creating new products. Here's the alphabet of lines. Again, lines are just created for drawings. We used all these. Hidden object lines, center lines. The only thing we didn't really do much of is our dimension lines. Some of you guys got to, but dimension lines are used to show how big things are. If you look at the diagram, the object down at the very bottom where it says dimension line 2 3/8, that says this block is 2 3/8 of an inch. All these things are called the alphabet of lines for drafting. Okay, again, a lot of this is a review. The system we use to create these is called CAD. We use it because it's quicker. You don't have to erase, start over. You can email them to people. There's just so many advantages to do it on the computer, and you guys probably understand that now, than doing it on paper. If you had to draw it, and let's say we changed the size of something, you'd have to erase it or even start over. Just think about architecture when they have a 3-story house or a 3-story commercial building and they change something. And let's say there's 30, 40 pieces of paper on the floor plans and you change one item, that's going to mess up all 30 papers. So if you hand drew those, that'd be a huge task to take. Now we just click a button and it changes all of them. Okay. And we've already went over engineering technicians. Again, you need to have some post-secondary schooling, but I guarantee you can probably find something out there that will hire a high school student, except you won't get paid very much, but the more school you go to, the more pay you're going to get. Okay. Again, this is all for communicating design solutions. Make sure you take the quiz right after. Have a good afternoon.